Now, dear student of class 12, now I'm going to start now after the puja vacation. I'm going to start the integration, the same chapter which we were doing before puja, that is some special form of integrations. I did some of the numericals related to the some special form of integrations. Now today we'll do first substitution, then some special form of integration. Now sir, integration cos x dx over under root 2 plus sin x, sin square x. This is sin square x. Now, if you substitute, let sin x equals to z, what we'll get? Derivative sin x is cos x dx equals to dz. Now, then the integration, I'll substitute over here cos x dx. Cos x dx is dz over under root 2 plus z square 2 plus z square. Now then I'll write both the functions should be in terms of quadratic form. First of all, I'll write z square first, then we must have square in the constant number, so I'll write root 2 square. Now this is in terms of formula. Integration dx over under root x square plus a square. Now the formula will be log of x plus under root x square plus a square plus c. Now then, I'll substitute the value of z. Now what is the value of z? Z is equals to sin x plus under root sin square x plus 2 plus c. This is your final answer. This is substitutions, then some special form of integration. Now same type of question. First what you have to do, you have to substitute the functions. Let derivative tan x is x square x. I'll write let tan x equals to z, and derivative tan x is sec square x dx equals to dz. Now integration sec square x dx is dz, so I'll write dz over tan x is z, so z square minus 6 z minus 16. Now then, what you have to do is you have to make this quantity in terms of perfect square form. You have to convert this quadratic equation in terms of perfect. We already did these things. Dz over, now directly I'll write a square minus 2ab plus b square minus b square minus 16. We did these things in the first video of this chapter. Now then, a square minus 2ab plus b square is integration dz over a square minus 2ab plus b square, means a minus b whole square, and minus 3 square is 9 minus 16. Now this is dz over z minus 3 whole square, minus 9 minus 16 is minus 25. Now we can write minus 25 as z minus 3 whole square minus 5 square. Now it is in terms of formula. Which formula? Integration dz over z square or x square minus a square. The formula will be 1 by 2a log of x minus a over x plus a plus c. Now this is 1 by 10, the value of z. Now what is the value of z? Z equals to tan x. So in place of tan z, I'll write tan x minus 8 over tan x plus 2 plus c. This is a required answer. Now the question is integration dx over x under root x plus 1. Now this kind of question, this is also substitutions, then substitution form of integrations that you have to use. But this integration, how you are going to tackle such kind of integration, you just remember these things are very, very important for the examination. Linear, under root linear. X is linear, under root quantity is linear. For this kind of questions, what you have to do is let the root, let x plus 1 must be equals to z. Then SBS, I'll write in the short form, this is squaring both sides. X plus 1 is equals to z square. Now then differentiate. Dx, the derivative 1 is 0, it is 2z dz. Now then substitute these quantities over there. Integration, dx is 2z dz over, now what will be the value of x from here? The x will be, now if I consider the, if I make a subject x, x equals to z square minus 1. In place of this x, I'll write z square minus 1. Then under root x plus 1 equals to z. These two quantities get cancelled. Now it is, the 2 is constant. I'll write outside the integral to dz over z square minus 1. Now we can square this quantity. 1 square is 1. Now it is in terms of formula. Which formula? X square minus a square. X square minus a square is 1 by 2a log of x minus a over x plus a plus c. Cancel. Therefore, substitute the value of z. Z equals to under root x plus 1 minus 1 over under root x plus 1 plus 1 plus c. This is the required answer. Now another question, but same type of questions. This is linear under root linear. Now for this question also the method is same. Let 4x plus 5 equals to under root 4x plus 5 equals to z. Now then squaring both sides, we'll get 4x plus 5 equals to z square. Now differentiate 4 dx is equals to 2z dz. 2 2s are 4. Dx is equals to 1 by 2 z dz. Now then I'll substitute over here an integral. Dx is 1 by 2 z dz. Now then, from over here you have to calculate the value of x. What will be the value of x from this? X equals to direct, right? Z square minus 5 over 4. In place of x, 2 into x is z square minus 5 divided by 4 into under root, this whole quantity is z. Z get cancelled. Now 2 1s are 2, 2 2s are 4. This 2 also get cancelled. Now we have over here dz over z square minus 5. Now I'll try to convert this integral in terms of formula form. So I'll write dz over, to convert this thing in terms of formula form, we must have a square in 5. So I'll write root 5 whole square. Now this one is also in terms of formula. Which formula? X square minus a square. The formula will be 1 by 2a log of x minus a over x plus a plus c. Therefore substitute the value of z. Now according to our substitution quantity, the value of z will be under root 4x plus 5 minus root 5 over under root 4x plus 5 plus root 5 plus say this one is the final answer. Now this is another type of substitution form of integration. This is linear over quadratic. The previous term was linear into under root linear. Now this one is linear over quadratic. For this kind of integrations, what you have to do is, this is important, this concept is very very important. What you have to do is, without writing its numerator, you just write its denominator, 2x plus 5. Now, after this, what you have to do is, next, you have to write its derivative over in the numerator. What will be the derivative of this quantity? This will be 2x minus 2. But according to the question, what we require? X plus 4. Then you have to convert this quantity in terms of x plus 4. Now, I have 2x over here. How to convert this 2x in terms of x? We cannot subtract x. We cannot do this particular numerical by this method. Subtraction, addition is not allowed over here. Only the division. To make it x, what you have to do? You have to divide this quantity by half. If you divide this quantity by half, and if you just open this bracket, 2 to get cancelled, it will be x minus 1 you will get. X minus 1. But what we require? X plus 4. If I add plus 5, so indirectly, if you simplify this quantity, you will get x plus 4 dx. Now, so I'll show you. Half 2x minus 2 plus 5. What will be the result? Multiply it, what you will get? X minus 1 plus 5. X plus 4. You will get x plus 4. Hope you will understand these things. Otherwise, I'll do once again the same step. I'll try to explain once again. Now, say, for this kind of integral, linear over quadratic. Linear over quadratic, what you have to do is, first you have to write its denominator, x square minus 2x plus 5. Now then, write down its derivative over in the numerator, 2x minus 2. Then after getting these things, then try to make this quantity x plus 4. How to make? If it is 2x means I'll divide it by half, it will be x. 2 to get cancel x. This one will be minus 1. To make it 4, we'll get x minus 1. If I add plus 5, what will get? X plus 4. Hope you'll understand. Now then, the method is that you have to divide, always same method. You have to divide individual quantities. Divide this quantity by the denominator. I'll add half, this half offset the integral. Now 2x minus 2 over 2x plus 5. This plus dx, then plus, divide this 5 by this quadratic equation. We'll get 5, I'll add outside. It will be dx only over x square minus 2x plus 5. After the separations, you will get two different integrals. First one, always substitution. Second one, form of integrations. Over here, I'll use substitution method. This is a little bit tough one. X square minus 2x plus 5 equals to z. Then differentiate 2x minus 2, then I'll write dx equals to dz. Now we're getting this quantity, 2x minus 2 dx. Now next is, I'll write half, then 2x minus 2 dx is dz over z. Now next one, the second integral, what you have to do is 5 plus 5 integration dx over, this is quadratic only, convert this one in terms of perfect square, this one will be a square minus 2ab plus b square minus b square plus 5. dz upon z is half of log mod z alert plus 5 integration dx over a square x minus 1 whole square minus 1 plus 5 half log, and the value of z is from here. Alright, x square minus 2x plus 5 plus 5 integration dx over x minus 1 whole square plus minus 1 plus 5 is 4. So I'll write 2 square half log x square minus 2x plus 5 plus 5. It is in terms of formula, x square plus a square, 1 by a tan inverse of x by a plus c. Now the final answer that I'll write, half log five by 2 tan inverse x minus 1 by 2 plus c. The required answer. Now dear student, with this numerical only I'll stop this chapter. Now from next video I'm going to upload integration by parts, another chapter. Thank you.